So, good morning, everyone. This is the another expert talk, online expert talk under the Aegis of the IQAC-IIC. And today, our speaker of the talk is Dr. Gaurav Kumar Jain. Dr. Gaurav Kumar Jain is the associate professor in the Delhi Pharmaceutical Science and Research University. He is also associated with the several professional organizations such as a vice president of Indian Pharmaceutical Association, Delhi State Branch. His potential research credential reflecting his capability as he has more than 3,600 citation, 30 H index, 7 PhD student he has supervised already, 3 TOT transferred to the various pharmaceutical industries, 12 crore grant he already faced from the various pharmaceutical industries and the government organization, 135 publications, 7 Indian patent, 1 US patent, and 5 books and 20 book chapters he has already published. He is the editor of the many reference book, and I would like to give the few of names like the Industrial Pharmacy by the Lackmin, and the research credential are reflecting I cannot explain in terms of the few words. So without wasting the time, I would like to welcome Dr. Gaurav Kumar Jain. Sir, thank you very much for joining the session and spare your time for this lecture. And today talk will be on the methodology to assess the bioavailability and the bioequivalence for the biological from the biological data. And I hope this calculation part would be very important for all the PG students as well as the UG students, those who want to conduct the bioavailability and the bioequivalence study. So thank you once again, Dr. Gaurav. Please start your lecture. Over to
Yeah.
you.
Thank you, Dr. Nitin and ISF Moga for giving me chance to present on this very important topic. This topic is particularly important for postgraduate students, particularly doing their research work, and for PhD scholars who are into their research work. Because nowadays everybody knows that without in vivo data, the papers are not generally accepted in good impact factor journal. So in vivo data becomes compulsory. So when we are doing some in vivo studies, so there are two types of studies which we are planning. The easiest one of them is pharmacokinetic study, or you can say step one is pharmacokinetic study, then step two is pharmacodynamics study. So in order to see whether our delivery system has delivered the drug to the right area in the right amount, we do pharmacokinetics study. But when we are doing pharmacokinetic study, the problem usually that comes is how to assess the data. So that assessment part we will be handling today, and I will give you three or four methods. So there are two, three methods which we can easily perform in the lab. Then there are one or two methods which we can do via software. So all four methods, a brief about all four methods I will discuss in my practical session just going ahead. So there are in particular three methods of calculating AUC. AUC is called as area under the curve, because what is bioavailability? Bioavailability is amount of drug that reaches the systemic circulation. The fraction of those that reaches the systemic circulation is bioavailability. So it is very important because the blood is the easiest thing that we can take from the body. Suppose we want to assess the drug in the brain also, then also we will take the blood and we will see what is the kind of distribution we are having. So there we are doing compartment analyzing also. But in the last, when we get the data, so how we achieve the data has two things. One is time points. So I am presenting you my screen where I have an Excel. So this 0, 1, 2, 3, 4 up to 12 hours is time points. So usually for immediate release dosage form, we take time points for few hours. But for controlled or sustained release dosage forms, it can be up to few days. For some implants or some some in vivo drug delivery system where requirement is for 6 months, where we are using some biodegradable polymer, this time frame can be up to few months also. So it is not restricted, but I am just taking an easiest example to explain how we are going to do calculation. So now there comes 2 points. First is the dissolution data, and then is the AUC data. In dissolution data also we have similar time points, but now comes the difference. The second row, the C row, is data for concentration. So at zero time point, the concentration of drug is zero in the body. I'm just taking a reference example. At 1 hour, the concentration is 1.2 microgram per ml, because we are determining the drug in the blood, so it is in ml. The quantity of drug we can determine via HPLC. We can go for LC-MS also, and there are several other techniques based on your analytical method. So we are getting some concentration, so I am taking a reference concentration. Now the difference between this data and the dissolution data is that you can see that the plasma concentration time profile. So this type of graph is called as plasma concentration, because this is plasma concentration and this is time. So they are called as plasma concentration time profile. So this is generally a U-shaped curve. So it's an area under the curve is bell-shaped curve. So it is not simple dissolution curve, because in dissolution what happens, the total amount of drug, cumulative drug, remains in the system. There is no sink condition which we are maintaining. तो जो हमारी रीडिंग्स होती हैं, so readings are adding on. So it is like 1.2, then 1.8, 2.1, then it will be 2.1 plus the extra amount of drug. Say 0.1, it is 2.2. Next is 2.2 plus that extra amount of drug. So you can see at 6 hours from 2.2 it is 2. But this cannot happen in dissolution, because there always the concentration will increase because drug is releasing. But in case of in vivo, now there is a difference, because with absorption, drug has some T half, and based on that, elimination starts. Because of that elimination, which is also a first order kinetics, the amount of drug in the blood is decreasing, because the liberation is there from the dosage form, but because of excretion, the amount of drug is decreasing. So the curve which we are getting is generally a bell-shaped curve. Now, you can see this graph. This is partial bell-shaped curve. Why this is partial? Because our last data has the reading of 1. It is 1 microgram per ml. If we have taken 24-hour time point also, then it might come 0, and we are having a perfect bell-shaped curve. Instead of this curve, we can have a perfect bell-shaped curve. But usually, because of the time limitation also, sometimes we restrict our studies to a particular time frame. And I am taking this particular example from master's and PhD perspective, because there we fix some time points, because we have to do comparative analysis. Now, taking these readings, we plot a graph. So graph can be plotted either on Excel, or it can be plotted on graph paper. Either of these methods we can use, and I hope all of you know how to plot the graph on graph paper as well as Excel. So the sample is there in front of you. Now, we have three methods for calculation from this graph for bioequivalence study. Now, see, there is a difference between bioequivalence and bioavailability. If we are doing only one, so there is no reference or there is no standard product, we are doing test for our product only, then this assessment is called as bioavailability assessment. But if we are determining with reference to some drug product or similar product, taking it as a reference or a standard, then it is called as bioequivalence study. So in simple, if we are making one plot, then we can assess the bioavailability. If we are comparing two plots, then we are doing bioequivalence assessment. Now, I am taking both the examples today. So suppose this is one of the graph. Now, how to calculate? So there are three methods. The first method is cut and weight method. The second method, which I am going to explain in detail, is counting square method. And the third method is trapezoidal method. So in books, these three methods are given, but in reality, we can have softwares also where we can do all the assessment in one click, or you can say we have to just put our data in, and in one click, we are going to get all the results. So we can go ahead one by one. What happens in cut and weight method? So first thing, cut and weight method is not the method for bioavailability assessment. It is for bioequivalence determination, or you can say when we want to do comparative analysis, comparative bioavailability testing. जब हमें compare करना है, then we have to do cut and weight method. So very important thing to remember in cut and weight method is that you have to always take x axis and y axis same. आप एक्सिस के अंदर चेंज नहीं कर सकते. जो आपने पहले एक्सिस लिया है मींस इफ यू सी दिस ग्राफ 0 to 12 and it is 0 to 2.5. सो ऐसा नहीं हम 2.5 के बियॉन्ड नहीं जा सकते, हम 2.5 के बियॉन्ड जा सकते हैं, बट हमारे ग्राफ का हर स्क्वायर, बिकॉज ग्राफ का स्क्वायर जो होता है आपका वो 1 सेंटीमीटर का होता है, हर स्क्वायर की वैल्यू आपकी 0.25 ही होनी चाहिए. यू कैन नॉट डिविएट फ्रॉम दिस 0.25 वैल्यू and you cannot deviate from this one value. So time point, you can see there is a difference between 1 hour. Every line represents 1 hour difference, and here in y axis every point represents 0.25 difference. तो हमें ये डिफरेंस मेंटेन करना पड़ेगा. रीडिंग हमारी जो भी आ रही है इसी ग्राफ में हमें प्लॉट करनी पड़ेगी. जब हम अपना डाटा ए यानी अपने टेस्ट प्रोडक्ट का डाटा और डाटा बी यानी अपने रेफरेंस प्रोडक्ट के डाटा को ग्राफ पेपर पे, डिफरेंट ग्राफ पेपर पे प्लॉट करते हैं, और प्लॉट करने के बाद सपोज करो हमारा ऐसा ग्राफ आ रहा है, हम इस एरिया को, इस ग्राफ पेपर को लाइन के अक्रॉस एंड टुवर्ड्स एक्स एक्सिस हम इसको कट कर लेते हैं. सो यू कैन से दिस एरिया विच आई एम शोइंग इट वाया कर्सर, इफ आई कट दिस एरिया ऑफ ए एंड दिस मच एरिया ऑफ बी, बिकॉज दोनों की रीडिंग्स अलग होंगी, दोनों का एरिया अलग आएगा. आप दोनों को कट करोगे, अलग अलग सेपरेट ग्राफ पेपर पे आपने प्लॉट किया है, दोनों को कट करके आप दोनों को वे करोगे. सपोज करो आपका एक का वे आया 50 mg और दूसरे का वे आया आपका 100 mg. आई एम टेकिंग इजीएस्ट रीडिंग इन ऑर्डर टू एक्सप्लेन यू. सो द डिफरेंस इन द बायोएबिलिटी इज 50%, और यू कैन से द प्रोडक्ट बी जिसका 100 mg वेट आया था, इट इज ट्वाइस एज मोर बायो अवेलेबल एज कंपेयर टू ए जिसका 50 mg वेट था. तो कट एंड वेट मेथड में आप जो एरिया ड्रॉ करोगे उसको कट करोगे, और कट करने के बाद उनको वे करोगे, और वेट में आपस में कंपेयर करोगे. जितना आपका डिवीजन आएगा उतना आपका एयूसी एनहांसमेंट या डिक्रीज होगा. दैट डिपेंड्स अपॉन विच न्यूमरेटर और डिनोमिनेटर यू आर सेलेक्टिंग. अ सिंपलेस्ट एग्जांपल इज वेट इज 100 mg डिवाइडेड बाय 50 mg, जो हमारे दोनों ग्राफ पेपर्स का वेट आया है, तो हमारा आंसर आ गया 2. दिस मींस AUC ऑफ योर सेकंड प्रोडक्ट जिसका 100 mg वेट था इज ट्वाइस हायर compared to AUC of the first product. This is first method which can be easily applied on the lab. Now, so master's student or bachelor's student can use this method in their project work. But if you are a PhD scholar or if you are a master scholar, I will advise you have to go for Excel. So there is another method which is called as counting square method. Now in this method, so again graph is there, you have to plot the graph either on the graph paper or on the Excel. So you assume this sheet as an Excel sheet also. Now what you have to do, you have to count the squares which are present here. Now in the counting of squares you have to keep in mind that जहां पे भी लाइन आपकी हाफ से ऊपर है, like this plot, this area and this area, but not this, तो हम इसको काउंट नहीं करेंगे. आपको फुल स्क्वायर्स एंड मोर देन 50% जो कवर हो रहे हैं उन स्क्वायर्स को कैलकुलेट करना है, उन स्क्वायर्स को काउंट करना है. सो व्हेन यू काउंट दिस, सपोज आई विल डू द रेफरेंस काउंटिंग. सो दिस इज 1, दिस इज 2, दिस इज 3, दिस इज 4, 5, 6, 7, 8, 9, then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 and so on. Suppose they comes out to be 40. I am just taking an example. ये हमारे स्क्वायर्स 40 आते हैं. फाइन. अब आपको क्या करना है, ये टोटल काउंट आया आपका स्क्वायर्स का 40, पर आर आपका आ गया बिकॉज नीचे जो डिनोमिनेटर है उसका वैल्यू जो है, जो एक्स एक्सिस है उसकी वैल्यू है 1. सो वी विल यूज दिस 40 into 1, और आपका यहां है 0.25. तो आप हर एक कॉलम की जो वैल्यू है, अगर किसी ने ग्राफ बनाया है और यहां वैल्यू लिखी है 0.5 और यहां वैल्यू लिखी है 2 hours, सी ग्राफ कैन बी डिफरेंट. ये तो मैंने आपको एक रिप्रेजेंटेटिव ग्राफ बनाया है, बट सपोज somebody is making 0 hours, 2 hours, 4 hours, 6 hours, and here 0.5, then 1, then 1.5. आपको वैल्यूज का सेम रखना है, मतलब गैप सेम होना चाहिए, बट आपका प्लॉट डिफरेंट है. Then what you have to do, you have to multiply your squares, number of squares, 40 into 2, because your R gap is 2, multiply by 0.5. But here in my graph, what I will do, 40 multiply by 1 multiply by 0.25. जब हम इसको मल्टीप्लाई करेंगे और जो हमारा आंसर आएगा, दैट इज योर AUC. अगेन, इससे हम कंपैरेटिव AUC भी कैलकुलेट कर सकते हैं, सिंगल AUC भी कैलकुलेट कर सकते हैं, क्योंकि मेरे पास टोटल स्क्वायर्स आ गए 40 मल्टीप्लाई बाय एक्स एक्सिस का डिफरेंस मींस 1 इंटू 0.25. ठीक है, इससे हमारा सपोज करो आंसर आ रहा है 10. सो दैट इज योर आंसर, दैट इज योर AUC, 10 माइक्रोग्राम per ml per hour. Fine, because you are taking it as 1 hour. So 10 microgram per ml per hour. Units are very, very important because everything changes with the unit. So that will be your answer. But now, if you calculate this through this, nearly we are getting more blocks, and our answer will come close to 19 or 19.5. Fine, you can try it at home. You can take the reading and calculate the number of squares, multiply it and get the readings. Then again, this is your first data. Then you have to plot again, taking same x-axis and y-axis, and you count the number of squares in the reference product also, and then you determine. So I am showing you another graph where you can see. Now here it is 0.1, here it is 0.2. Fine, graph is there, but you can see number of squares increases, and as number of squares increases, you can see the value of AUC. So this is the calculated value of AUC here, 39, and here you can see 19.5. This is calculated value of AUC. I will show you how we have calculated this in our next step. तो दोनों की कैलकुलेटेड वैल्यूज में आप देखोगे डबल का डिफरेंस है, एंड इफ यू काउंट द नंबर ऑफ स्क्वायर्स, द स्क्वायर्स काउंट विल बी डबल फ्रॉम हेयर टू हेयर. फाइन, now you can see the values also, 0, 1.2, 1.8. In next graph you can see value 0, 2.4, 3.6. So if you can see, I have just doubled the value, have doubled the AUC. Now double the AUC, you can see number of squares also doubled. Now you can see it is not square because this graph is bit modified. If I will do like this, it will become square. So it hardly matters because number of squares will remain same. There is no change in the reading or data if I will enlarge or compress the graph. Fine, but this plot I have shown as a reference to Excel sheet also, to graph sheet also. So you can do simply, you can plot two graphs on your graph paper, count the squares. You have to keep in mind the axis should be same for both the graphs. You have to keep in mind that you have to count only the squares which have value greater than 50%. So this we will count this one, but we won't be counting this one, because here it's 10% or 12%, not more than that. So that's why we are not going to count. Fine. So in order to generalize the result, we will be counting all the blocks which have line or cross section more than 50%. So remaining blocks we don't count. So it will nullify the result, and we will get a very close result, which is close to absolute result. So if you will count it, probably you will get values 19 point something, if not exactly 19.5. Now next method is trapezoidal method. In trapezoidal method, you can do via two ways. Either you can do manually or you can do via Excel sheet. Manually means, see, every row is a trapezoid here. If you can see 1, 2, यहाँ से हम start करेंगे. So okay, I'll take some column here to show you in a better way. I'll take this and I'll change its color also. Fine. So if you see, this one is your first trapezoid. Fine, I'll just reduce it, or I will put okay, now it's better. So if you see, this is your first trapezoid. Now if you see, this will be your second trapezoid. Now if you'll see, this will be your, from starting here to down is your third, this is fourth, this is fifth, this is sixth. So manually you can calculate area of all these 12 trapezoids. आप इन 12 के 12 trapezoids का area calculate कर सकते हैं manually. The formula is very easy. So you have to calculate this portion plus this portion. So if you take the formula, what is the formula? Formula is both bases ka sum of both the bases divided by 2. So here if we see the bases, so this is one base, this is one base, so sum of both the bases. So if you can see, this is 0 first base. I'll take second example. I will take example of this trapezoid. Fine. So if you see, the first point is 1.2 till here. This is 1.2. Fine. This is first base, and second base is this, which is the next reading 1.2, and this is 1.8. Fine. So you have to add 1.2 and 1.8. Fine. You have to divide it by 2. Fine. This is the formula. Both bases divided by 2. Fine. So this is base 1. This is base 2. You add it. So base 1, base 2 here. You add it and divide it by 2. Multiply by height. Height in every case is this. This means if we see, height in every case comes out to be 1 here. हर ट्रेपेजॉइड की हाइट आपकी 1 है, बिकॉज आपने रेफरेंस में क्या लिया, बना. तो हाइट आपकी सेम है सारे ट्रेपेजॉइड्स के लिए. आपका डिफर क्या कर रहा है, आपका डिफर कर रहा है बेस. पहले ट्रेपेजॉइड के लिए बेस है 0 एंड 1.2. सेकेंड ट्रेपेजॉइड के लिए बेस है 1.2 एंड 1.8. थर्ड ट्रेपेजॉइड में 1.8 एंड 2.1 एंड सो ऑन. फाइन. तो 12 के 12 ट्रेपेजॉइड्स आपको ड्रॉ करने हैं, आपका बेस निकालना है. सबका जो don't use this reading because this reading is calculation via software which I will show you next. So ये हमारा डाटा है बेसिकली. यहाँ पे ये आपका ट्रेपेजॉइडल का बेस हो गया और ये आपके ट्रेपेजॉइडल की हाइट हो गई. अगर आप हाइट देखोगे अप टू 10, फाइन, 8 से 10 पे हम जा रहे हैं, तो आपको जो ये वाला ट्रेपेजॉइड बनाना है, फाइन, this will be like this from here to this point. So 8 to 10 का ट्रेपेजॉइड और 6 to 8 का ट्रेपेजॉइड आपका 2 आवर्स का होगा और आपकी वैल्यूज क्या होंगी. सो फॉर्मूला क्या बनेगा आपका, 1.7 plus 2, so 3.7. 3.7 divided by 2 multiply by आपका हाइट कितनी है, 8 minus 6, that is 2. That will be your answer for this trapezoid. ऐसे आपको सारे ट्रेपेजॉइड्स का एरिया निकालना है. सारे ट्रेपेजॉइड्स का एरिया निकाल के आपको सबको ऐड कर देना है. That again will come to close to 19.5, which is AUC for this particular readings. Now another method is that you can do it in on Excel. जो हम काम बोल रहे हैं वो हम एक्सेल में, मैनुअल काम हम एक्सेल में भी कर सकते हैं. Now if you will see, I have put the same formula. So आप फंक्शन पे जाओगे, इक्वल का साइन यूज करोगे, डबल ब्रैकेट लगाओगे, then you add C2. Now what is C2? C2 is this reading. Fine. C2 is the reading which you are getting 0. Fine, is C2. आप देखो, see this row to this column plus C3. C3 is next reading 1.2. So again we are doing same thing, 1.2 plus 0 divided by 2. This is there in the formula. Fine. I'll just so divided by 2 multiply by, this is multiplication sign, multiply by, मैं एक बार बाकी सारी रीडिंग्स एक बार डिलीट करता हूं, ठीक है. multiply by 2, multiply by B3 minus B2. Now B3 here is 1, B2 is 0. So 1 minus 0, the same formula which I have told, base 1 plus base 2 divided by 2 multiply by difference in the height. So difference in the height here is B3 minus B2. आप फॉर्मूला लगाओ then same formula, you just scroll the values, it will automatically calculate because this formula changes the reading. Now if I click this, you can see next two columns are there, C4 plus C3 and minus के अंदर B4 minus B3. In next C5 plus C4, B5 minus B4. So on it will calculate. So in a one step, in a one go, just putting a formula, you are able to get the reading. You have to always delete all the minus values, fine, and you will get the AUC. So this method is called as trapezoidal method. Again, there are two methods here. The first method is either you can do manually, when you can determine the area of each trapezoid and you can add the area to get the result, or with one click, with putting the formula, very easy formula, select your first column, then second column, add that column of concentration, divide by 2, multiply by column preceding column minus succeeding column of the R time point. So that will give you the result in one go. Fine. So this is trapezoidal method. So we have done cut and weight method, we have done counting square method, and we have done trapezoidal method. The last method which is there is by software. So I will just remove this.
Dr. Gaurav, can you tell me the name of the software which you are going to use?
Yeah, I'm just coming on to this because I'm opening that in my window. So you can yourself see, just a moment, it is taking bit time. So I put those readings only. Now, Dr. Nitin, it is visible. My screen is visible.
Yes, yes, yes.
Okay. So again, same reading is there. If you can see 0, 1.2, 1.8, 2.1, same calculation is there. And what you have to do, there is a software which is called as PK solver. So there are multiple software. WinOnline is the most widely used software with many features, but it's very expensive and we have to buy its subscription. So subscription cost in lakhs. So I'm giving an example of PK solver, which is free add-in available. So you have to create add-in. तो आपको डाउनलोड करना पड़ता है सॉल्वर, ठीक है. ये फिर आपको बताएगा आपको कैसे ऐड इन करना है. Once add-in is there in your system, you have to just open any Excel, you put your readings, click add-in, there will come PK solver. In PK solver, there are multiple options come. Now, since if you are doing oral, we have to go for extravascular. If you are doing for IV sustained release or IV immediate release, एक होता है IV बोलस is immediate release, IV infusion यहाँ जहाँ धीरे धीरे IV आप देते हो, जैसे कि जब हम किसी को न्यूट्रिशन चढ़ाते हैं, किसी को हम ग्लूकोज चढ़ाते हैं, तो वो IV infusion होता है जहां एक एक ड्रॉप बॉडी के अंदर जाती है. दिस मींस कंट्रोल रिलीज और सस्टेन्ड रिलीज. सो देयर इज आईवी इन्फ्यूजन, आईवी बोलस, एक्स्ट्रावेस्कुलर. ये तीनों आपने बायोफार्म के अंदर कंपार्टमेंट मॉडलिंग के अंदर पढ़े होंगे, बिकॉज हियर वी चेंज कंपार्टमेंट मॉडलिंग. ऑल कंपार्टमेंट मॉडलिंग डिपेंड्स अपॉन हाउ यू आर डिलीवरिंग द ड्रग. सो एक्स्ट्रावेस्कुलर मींस ओरल, देन इट इज वन कंपार्टमेंट जहां आपको डिस्ट्रीब्यूशन नहीं लेना है, या टू कंपार्टमेंट. सॉरी. So it entirely depends upon what kind of data you want to get. So here I am clicking one compartment. So there a graph pad will come. It will show time and concentration. So time data, you click here and you know this is your time data. You put your time data here. Again, a simple one click. Concentration, you click here. This is your concentration data. Put your concentration data. So what you are doing, you are just having time data and concentration data जो आपका एक्सपेरिमेंट के थ्रू आएगा, चाहे आप एनिमल स्टडीज करो, चाहे आप ह्यूमन स्टडीज करो. डिफरेंट टाइम पॉइंट्स पे आप ब्लड सैंपल कलेक्ट करोगे, प्लाज्मा को उसमें से सेपरेट करोगे, उसमें अपनी ड्रग को एनालाइज करोगे वाया HPLC, LCMS और योर डेवलप्ड मेथड. उसके बाद आप डाटा एक्सेल पे डालोगे और ये डालने के बाद आप डाटा इस PK सॉल्वर में डालोगे. Then you have to change your readings. Suppose I am taking this R, it can be in minutes or days depending upon your data. So I have selected R. Here it can be microgram or nanogram per ml. If my readings are in nanogram, I will put nanogram per ml. If it is in microgram, I will put microgram in ml. Here for bioequivalence, we can put the dose also. Like I can put 100 mg dose. So it will give you exact bioavailability, because if you can see the formula of bioavailability, it is AUC of test divided by AUC of standard multiply by dose of standard divided by dose of test. तो अगर आपका डोज डिफरेंस है तो आप यहाँ पे उसको ऐड कर सकते हो, एंड इन वन क्लिक यू हैव टू जस्ट रन. Now the beauty is here you can get all type of data in one click. See, I'll just minimize this. I'll just minimize this. Now you can see you have time, concentration, you have log concentration value automatic calculated by the software. Okay, then you have all the parameters. You have A, you have KA, you have KT, then you have plot also. So this appears to be similar plot जो हमने अपने पहले वैल्यूज में बनाया था. पैरेलली मैं इसके और कोई विंडो नहीं खोल सकता, दिस इज रिस्ट्रिक्टिव. अगर मैं और कोई एक्सेल खोलूंगा तो ऑटोमेटिक ऑफ हो जाएगा. फाइन. सो यू कैन कैलकुलेट टी हाफ. सो टी हाफ इज 1.8. योर टी मैक्स इज 4 आवर्स. मींस योर टॉप पॉइंट जो आपका टी मैक्स है जो एयूसी को रिप्रेजेंट कर रहा है, ठीक है, दैट इज योर 4 आवर्स. सॉरी, फॉर जो सी मैक्स को रिप्रेजेंट कर रहा है दैट इज योर 4 hours. Fine. Then you can get data of AUC. So AUC 0 to T. Now this is again very important. You can see AUC 0 to T. I have bolded is 19.6. जब हमने सॉफ्टवेयर से प्लॉट करी वो 19.5 आ रही थी. तो यहाँ वैल्यूज और ज्यादा एक्यूरेट आएगी, बिकॉज वहां ट्रेपिजॉइडल में आपने हाफ से ज्यादा वाले ही स्क्वायर्स काउंट किए थे, उनसे कम वाले स्क्वायर्स आपने हटा दिए थे. बट फॉर योर स्टडीज via that simple thing you can get approximate values. 19.5 is very close to 19.6 which we are getting through this. Now you can also see this is 0 to T and 0 to infinity is 26. Now the difference is आप देखोगे ग्राफ के अंदर जब हमने ट्रेपेजॉइडल ग्राफ प्लॉट किया था, हमने वो ग्राफ यहीं पर रोक दिया था 12 आवर टाइम पॉइंट पे. So this 0 to T means up to 12 hour time point we are getting this value. But if you extrapolate this graph in your graph paper also, means in your trapezoidal method, in your cut and width method, in your counting square method, in all the methods, if you extrapolate this and you get the value 0 in the last, whatever time point it is, that means it is infinity time point. Because आपको time point नहीं मालूम, आपको पता है आपको रीडिंग 0 लेके आनी है, तो आप इस रीडिंग को एक्स्ट्रापोलेट कर रहे हो अप टू 0. जो भी आपका टाइम पॉइंट आएगा जब आप उसको कैलकुलेट करोगे तो आपकी AUC की वैल्यू 26 आएगी. तो सेम रीडिंग से जो डाटा हमने इसमें लिया है, आई विल जस्ट शिफ्ट ओवर टू डाटा 1 2 3 4 1.2 1.8, इसको आप एक्स्ट्रापोलेट करके ग्राफ में जब 0 कैलकुलेट करोगे, यहाँ पे जो भी टाइम पॉइंट आएगा जब उसके साथ आप किसी भी मेथड से इसको बनाओगे तो आपका AUC 0 टू इंफिनिटी भी कैलकुलेट होगा और वो आपका क्लोज टू 6 आएगा. बट इसकी ब्यूटी क्या है, ये आपको AUMC, MRT सब कुछ दे देता है इन वन को. इन ग्राफ वी हैव टू कैलकुलेट ईच एंड एवरीथिंग. सो दैट्स द डिफरेंस बिटवीन द सॉफ्टवेयर. तो इन्होंने प्रेडिक्टेड कैलकुलेशंस पहले से करी हुई है, आपको बस जस्ट अपनी रीडिंग डाल के रन करना है. सो these are all the methods. Wilnon is also this. It is more advanced. You can get more options, more compartment modeling, more results there. But result will be the same.
All right, sir. Thank you very much for this wonderful presentation on how we can calculate the bioavailability and the bioequivalence data. All your health is not looking very good, but still you put your extreme effort for this presentation, and I think this was the till date I am getting this presentation extraordinary, because you share all the methodology, all the software tools, all the manual method for the calculation of this data. Thank you very much once again. Now for the conclusion of the session, I would like to invite our director, sir, Dr. Respected GD Gupta, sir. Sir, over to you.
So thank you very much, Dr. Nitinji. So first of all, I am very, very thankful, Dr. Gaurav Jainji, for accepting our invitation, and you have given your very precious time for this ISF dialogue series. And I also welcome you, sir, from ISF College of Pharmacy as well as our IQAC dialogue series. So as you know that only a few people, those who are the working in bioavailability and bioequivalence in the pure form. And one of them, late professor, MC Goel sir. So he established some number of the software on Fortran language. And this I am very lucky. I did the work some you can say month, 2 3 months with the professor MC Goel sir, and only few peoples in the statistics they are the working in the bio availability and bioequivalence in the pure form. So you have given the very excellent lecture, and only my query is this one. Nowadays, people is the required. You have already mentioned the cost of the software in the lakhs. So obviously, now India is the quite comfortable in the IT center, and let us consider like you people's and very experienced, vast experience like that, and how many factors is the required. And if we can do some of the collaborative works with the IT sector, then we can develop some of the small software at a only cost in the rupees, not in the lakhs, in the so
Yes.
that it will be the comfortable to each other. And person they can be also involved in the viability and pharmacokinetics, data analysis, data interpretation. In the initial slide you have already mentioned, if you can perform any activity and obtain the data in the form of the in vitro form, so publication of the paper it will not to acceptable if you not perform the in vivo study. So that is
Yes,
very,
Nitin.
very true form. And nowadays it is the highly loaded and the requirement, because now most of the you can say herbal drug delivery system and all the Ayurvedic companies, now they are moving toward the testing of the study, and they are also interested to publish the paper. So dear gentlemen, those who are the listening of the lecture, this is the one of the very important field and vast field and required. This is the purely mathematics field, because what you have given, how much you have given, where it will reach, how much time, and how it can be degraded or metabolize like that. So each and everything you can find out on the basis of the data. So these thing is
I think there is
and
some
pure
network.
form in the offline mode, so that we can give the actual you can say values, as well as how to determine and how to apply the thesis either in maybe M form or the B form like that. So thank you very much. You have given the mathematical approach, excellent approach, because nowadays most of the students they are the moving towards the moving out of the mathematical application. I know that in the physical pharmacy, pharmaceutical engineering, there is the no any pharmaceutical calculation even in the main examination like that. What this is the need today, so that we must be a reasoning based and competent in the pharmaceutical education. Nowadays this is the wonderful field. So thank you very much the organizing committee, IQAC, Dr. Siddharth Man, coordinator and moderator of today's lecture, Dr. Nitinji, and thank you very much, Dr. Gaurav Janji, for accepting the invitation and deliver a excellent talk for the pharmacy professional, not only for the ISF College of Pharmacy. It will be available on the YouTube and the long time, so that person take the benefit of this lecture, and some of the people also personally connect to you through the email or like in the other of the media source like that system. So thank you very much, sir.
Thank you, sir. Thank you. Thank you.
Thank you, Dr. Gaurav.
Thank you, Nitin.
Thank you very much.
Nitin sir, you can stop the recording also. Nitin sir.